Okay, we're going to simplify complex fractions with polynomial denominators. So I already made a video on simplifying complex fractions with monomial denominators, and I went over two specific methods. Method 2, which I'm going to use in this video, where you identify the least common denominator and eliminate all the denominators, is going to be the best method to use as math gets more complicated. So we're going to focus on this method here. If you want to use the other method, which is multiplying, rewriting it as division and flipping and changing and all that, then I would check out that other video. So first we have to identify the least common denominator. In all our denominators, we have x plus 2, x plus 5, and x squared plus 7x plus 10. The LCD, well, the first thing we need to do is factor out that expression. And that trinomial will factor into x plus 2 times x plus 5. So that's actually going to be our LCD because those two binomials, we can change all those fractions and they include one or both of those pieces. So this one actually works out very well. So we're going to take this LCD, x plus 2 times x plus 5, and we're going to multiply it in the numerator and the denominator of our complex fraction. So when we're multiplying, what I wrote in red is actually 1, the same thing divided by itself. It might be easier to put that over 1 as well so that you understand you're multiplying the numerators of each piece. So we'll do the denominator first this time because it's going to be a little easier. X squared plus 7x plus 10 is the same as x squared plus x plus 2 times x plus 5. So those are going to divide out, which means the denominator we're going to get is 5x plus 16. So we found the LCD, we multiply, now our denominator is not complex. Our numerator, we have a binomial in our numerator, which means we're going to have to distribute this. So when we take the x plus 2 times x plus 5 and we multiply it by this first term, the x plus 2 in the numerator and the x plus 2 in the denominator are going to cancel. So I'm going to have my 8, and the thing that is not going to cancel is the x plus 5. When I do the same thing and I multiply this expression times the 12 over x plus 5, what's going to cancel in this time is the x plus 5 because that's in the denominator. The 12 is still going to be there, and what's not going to cancel is the x plus 2. And that's what we would get when we multiply the top. You can write it all out and see them in separate pieces. So our denominator, or our numerator now, we still have to simplify. So we have 8x plus 40, 12x plus 24. When we add that together, we get 20x plus 64 as our numerator. And our denominator is 5x plus 16. So it's very easy to say, I am done. You are not. It's just a matter of looking at the problems and figuring out what else can I do. That's what you want to ask yourself. Is there more? Can I do something else? The numerator here has even terms, which means we can factor our numerator and simplify it. So we can actually factor out a 4, and if we take out a 4, divide it out, we get 5x plus 16. And look at that, our denominator is also 5x plus 16. So now we have common terms on the numerator and denominator. We're going to cross those out, divide that, and our answer is going to be 4. So you always want to try to reduce, factor and reduce. Even when you think you're done, you might just have to take an extra step. So we'll do another example of this. So here we have another complex fraction. Our numerator has 2 parts, and our denominator also has 2 parts. So this is going to get a little crazy. Again, we're going to use method 2. We're going to find the LCD, multiply it by everything. This is the most efficient method, so that's why we're going in this way. So our LCD, if we look at our denominators, it has to have an x minus 5. That's the only way it's going to get rid of those x minus 5s, including the 5 minus x. So that was covered in a previous video. The x minus 5 is going to help with that 5 minus x. That monomial x right here, though, is by itself. So you have these x plus 5s and the 5 minus x, which would be taken care of by that binomial. But the monomial x also has to be in your LCD. So that's our LCD. In factored form, it's going to be x times x minus 5. So we're multiplying that on top and bottom. So we're going to do x times x minus 5 on top, x times x minus 5 on the bottom. So I'm going to put this over 1 so that you see it. So the other thing I'm going to do is I'm actually going to write it on both sides. So this expression has to be distributed to both of these. So I'm just going to write it on one side to distribute on the left, and then I'm going to write it on the right side to distribute it here. So essentially what I'm doing is I'm breaking up the problem and I'm writing it as the distribution right now. X times x minus 5 over 1. So if we wrote this out and distributed this times this, this times this, this times that, this is what it would look like. This is what you get. So we essentially have 4 different problems. So we have 2 in the numerator, 2 in the denominator. In the numerator, well, let's do the denominator first, actually. The x, numerator and denominator are going to cancel. So what we're left with in our first part of the denominator is 2 times x minus 5. The second part of the denominator, there's an x minus 5 that we can cancel. And what we're left with now is 3x. So that becomes our denominator once we multiply by the LCD. So now when we look at our numerator, the x minus 5 and the 5 minus x are not the same. When you divide these, you're left with a negative 1. So essentially what you have is 5 times negative 1x. That negative is very crucial to remember when you have those opposites in there. The other part, the x minus 5's cancel. Those are exactly the same. So we're left with 6x. And now we could put pieces together. We have negative 5x plus 6x in our numerator. Our denominator is 2x minus 10 plus 3x. So we get 1x over 5x minus 10. So get into the habit. You just start looking, taking a step back and figuring out if there's something you can do. The denominator can be factored. There's a 5 that's common. So if you factor out the 5, you get x minus 2. And that would be your answer. Now, you can leave your answer as x divided by 5x minus 10. The key is sometimes that won't work. So if you factor it and there is a common factor on top and bottom, you will always have to get to this point in order to be able to see those things in there. But that's how you simplify complex fractions if the denominators are polynomials.